Some exponential functions cannot be solved by getting like bases. And so we are going to look at a new rule. It's either, you can think of it as a rule, property, or technique. So your goal is to always isolate the base to the power and have that equal to another number or another base. So a lot of times you're going to have to use operations to get rid of anything that's being added, subtracted to this base to the power. So it needs to be just one base to one power. Right? And so what you're going to do is you're going to be doing this on your calculator. And a lot of times we want to pay attention to how we're going to round. And so today we're going to round to 4 decimals, which means that to the right of the decimal point, you need 4 places. So you're going to look at the 5th place to consider your rounding. And so the way that we are going to use our calculator is once you have it in this format, you're going to use the natural log or the LN button on your calculator. And so kind of the strategy, all right, that you're going to take is that you have to, whatever you do to one side, you must do to the other. So I'm going to take the LN of the left and the LN of the right. And so what's happening here is, since I'm using this operation that whatever you do to one side, you do to the other, the LN button in your calculator, if we want to, we could put in the LN of a number and figure out what that is as a decimal. All right, so LN is just another function. It's called your natural log function. We'll look at what that looks like as a graph later, but for now we're just going to try to understand how to use the property. Now, the side that has the variable on it, you have a rule that anytime you take the ln of a number where there's an exponent, that this exponent can now jump out front and become a multiplicative factor. And so that's the same thing as x times the ln of just the base. All right, and so what happens is when you take the ln of a base with an exponent, it doesn't matter what the exponent is. It can be a variable, it can be a number, but that exponent is now allowed to jump out front. But it's only allowed to do that because of this property of ln. Right? Now the ln of a number, right, is just another number. And so this is kind of like the same as when you're solving a one-step equation where you have a number times a variable. And so to isolate x, we're going to leave the ln of the right, and we're just going to divide both sides by the ln of what it's attached to. And this all has to be done in your calculator. There's no other real way to do this unless your a and your b are very specific numbers, which we'll discuss later. So let's look at this strategy. All right. So for example, all of these we want to be able to solve and again round to 4 decimals. All right, and we'll start off with something that looks like this. So you want to have your calculator. Sorry about that. All right, so when you're solving, first it's already in the correct format. You have your base to a power equals another number. And so we're going to start with our strategy, and we're going to say I'm going to take the ln of the left and the ln of the right and put those bases in parentheses. So again, that allows my x to jump out front. All right. And you must show all of these steps. I don't want you shortcutting. All right. And so this right here, the ln of 19 divided by the ln of 3 is what we consider an exact answer or an exact value. All right, it's just like if you have a fraction, you know, like 4/3. This is my exact answer. And so we're going to approximate to 4 decimals. And this is where your calculator is going to be important. So you need to find out where on your calculator is the button that says ln. All right, and so on different calculators, it's in different places. And so on this calculator, I can just hit the ln of 19. Make sure you end the parentheses, divided by the ln of 3. And then this number I can round to 4 decimals, which means that I want 1, 2, 3, 4. And this number 4 is not bigger than 5, so I'm going to chop it right here at the end of 1. And so the value for x that would make this true is approximately 2.6801. And so you can see that your process is a little bit longer, but you're going to be able to use your calculator now. Right. So let's do a few others. All right, again, if you have something that looks like this, right, where you don't have your base isolated, you must first perform any operations that are necessary to make that happen. And so you have to make sure that it's this base is equal to a number. You cannot have this 3, and you're not allowed to multiply 3 and 15 together, because in order of operations, you must always deal with exponents before you multiply. So you can't do that. All right, so the first step that I'm going to need to take is I need to divide both sides by 3. Now, if this fraction simplifies, that's great, but if not, you need to leave it as a fraction so that way you can do the work in the calculator. Do not round this or do any kind of decimal approximation. Now I have my base to my power equals another number, and I can take the ln of both sides. And when you take the ln, leave the 23 over 3, again in parentheses, because I need the natural log of the entire fraction. Now again, it's going to let the entire exponent jump out front. So this is 2x times the ln of 15 equals the ln of 23/3. And now when I go to divide, I need to isolate x, and it's being multiplied by this number and the number 2. So when I isolate my x, I'm going to divide both sides by both numbers. The 2 and the ln of 15 are both going to go down in the denominator of the other side. Right. Again, you're going to have to pay attention to how your calculator works. All right. So for me, I'm going to press the ln of 23 divided by 3, and that's the numerator. But when I get ready to say I need to divide by that denominator, I need to tell the calculator that all of this is happening in the denominator, and I can't just put in 2 times ln of 15. So I'm going to use some parentheses to actually tell my calculator that. All right. And so what you're going to notice is that I need this outer set of parentheses to show where my denominator is, and then the operations that are happening in that denominator before I can hit the equal sign. All right, so 3, 7, 6, and this 7 is going to make this go up to 1. And so that's my approximation for the value of x that I would need to make these both true statements. Okay. So last but not least today, so I have 13 to the m minus 3 plus 2 equals 41. So again, I have an operation happening to my base. All right, so again, I'm trying to isolate this base right here, which means I need to subtract 2 from both sides. All right. When I subtract 2, I'm going to end up with 39 on the right. All right. And so this is similar to yesterday where, 13 and 39 in my brain, I think that they have something in common. But again, I can't raise 13 to a power to get 39. 13 to the first, 13 squared is going to be nowhere near 39. All right. So now I'm going to take my ln, all right, of both sides. And again, that allows this entire exponent to be written out front. And when I do that, I need to put that in parentheses, all right, because it's a multiple term expression. Right. And so now I have that exponent, that binomial, that's being multiplied by the ln of 13. And I can't just divide because this is not all multiplication. And so I have 2 options. I can either distribute, or I could leave the m minus 3 alone for a second and just divide both sides by the ln of 13. And then when I'm done, say the way to isolate m would be to add 3. So I'm going to leave the ln of 39 divided by the ln of 13, and then whatever that fraction is, then I'm going to add 3. So the plus 3 is happening after I put this fraction in my calculator. All right, so again, the ln of 39 divided by the ln of 13. And I'm actually going to hit my equal sign first before I add 3. All right, and so again, this is approximately 4.4283.